Yeah, and I'm recording why first, because it's unit 3 and unit 4. I'd like to record them, and I'll put them back in your unit 7. Okay. Also, we are doing number 5. And how do I answer this question if it's in a test? That's what we're doing right now. Okay, so the first thing I want to do, since I have my calculator, is put the data in my calculator. Okay, and I go to STAT, and then I'll put in the random variables in L1. So I have 4, enter, 5, enter, 6, enter, 7, enter. So the random variables are gone. Then I'll go to L2 and put the frequencies. So I got 18, enter, 21, enter, 21, enter, and 35, enter. When you finish, like we said in unit 1, eyeball all the things you enter. People make mistakes. Now you have 2 lists. List 1 is for random variables. Unit 2 is frequency. But we shall be finding probability. Let me quickly find probability also. But before I find probability, I want to do one variable start of L1 and L2 because I want my calculator to add even though I know I can add it, I want my calculator to give me the sum of all these frequencies. So I'm going to do one variable start of L1 and L2. I better tell my calculator that I'm doing a group data where the random variable is in L1 and frequency is in L2. You better know you have to do that. And I will calculate. When I calculate, tells me that the sum of all the frequencies is 95. I know I can do it by myself, but any small mistake will throw you off. So the sum of all the frequencies is 95. So now I'm about to find the probabilities and put them in L3. So I'm going to go back and then go back to edit. And then I'm going to tell my calculator to find the probability of each random variable. Another way of saying 18 divided by 95, give me what it is. 21 divided by 95, give me what it is. Well, this data is not a lot. Suppose you have a data that contains 15 random variables. You don't really want to be doing them by hand. That's why you need to know how to use your calculator. So I want to tell my calculator that L3 is the probabilities to 4 decimal places. So I can go to, if I like, because I'm told to put it to 4 decimal places, I can go and tell my calculator, go to mode and put it to 4 decimal places. If I like, don't have to. And then I second quit. And then I'll quickly go and find the probabilities like I wanted to do before. Okay, so arrow up to L3, type in what you want your calculator to do. The probabilities is what I'm looking for. So I'm going to ask my calculator to divide every frequency, L2, by what? Total frequency, which is 95. Divide every frequency in L2 by total frequency, which is 95. And it does that for me. Because I asked for 4 decimal places, it gave me 4 decimal places. Then I will go and complete this column here, right? It told me construct a discrete round your answer to 4 decimal places. Do you think it's very easy? It's easier because you know how to use your calculator. Okay? Because this is easy anyway to do by hand. But I'm saying, suppose you have a distribution that has 15 random variables or 20 random variables. It will be longer. It will take you more time. And you need to finish a test to make an A. You need to finish the test to make an A. If you do 2 questions out of 15 in a test, no matter how accurate those 2 questions are, you fail the test. That's why you need to know how to use your calculator with speed and accuracy. Is that clear? All right, so I have got that. Then let's go to the next question and see what it says. It says draw a probability distribution. Okay, so you ask yourself, what is the highest probability? The highest probability is 0.1 decimal points is 0.4. And random variables are in the base, which is x. So now probabilities are on y-axis because that's why it's called probability distribution. If it is a frequency distribution, frequency is in y. If it's probability distribution, probability is in y. Okay. All right. So now you know that the highest probability is 0.4. You can put 0.5 there. Because discrete, it is discrete. It cannot have decimal. Therefore, you must draw lines. You cannot draw a histogram. Are you listening over there? Are we together there? Okay. You cannot draw like a histogram or bar graph. No. This is a probability distribution. It has to be bars, lines, line graph. I mean, just straight lines. Okay, so we know that. You can just do that. And then the next question is find the mean. To find the mean, you go back and do your one variable stats of L1 and L2. All right, so I'm going to do one variable stat. So I'm going to STAT, calc, one variable stats. I want you to know that you're doing one variable stat of L1 and L2. If you do only L1, you'll be screwed up. Is that clear? All right, so my calculator still have L1 and L2, so I'm going to calculate. All right, so I'm told to find the mean. I want you to know that mean is also called expectation. Do you know that? Okay, suppose the question says find the expectation. Expectation is the mean. And if you're told to find the expectation, to how many decimal places? They say 1. So what is the mean to 1 decimal point? That question. What is the mean to 1 decimal point? Somebody. 5.8. Correct. Okay. Let's go to answer another question. What is the compute the standard deviation of the random variable? How would you get that? By the way, be careful. You are told to compute the standard deviation, which is sigma x. In other words, find the population standard deviation. Find the parameter. So what is your answer to 1 decimal point? Somebody. 2.3. Are you? The standard deviation is 1.1. Don't you see? Okay, 1.1. What about if you're told to find the variance? How would you find it? Square the standard deviation. And by the way, if you can also do var statistics if you forget, and then the standard deviation is number 4. If you hit enter, you get it, and then square it and get your variance. Suppose you're told to put the variance to 1 decimal point. What's your answer? 1.3. Be careful. Small things. Who said 1.4? Is that what you have? Something is wrong. You should 1.3. The variance is 1.4, 1.3. Did anybody get 1.3? So one of your data is wrong. You put something in, something that is wrong. You see if I find a mistake? Okay. All right. So Also, that's about number 5 because we have to be faster, okay? So let's be faster. Let's go to number 6. Suppose Aaron is going to build a playlist that contains 13 songs. In how many ways can Aaron arrange the 13 songs on a playlist? They didn't tell us it is permutation. They did not tell us it's a combination, or said in how many ways. In other words, Aaron is going to take all 13 of them at a time. Build 13 songs, taking all of them at a time. So it's going to be 13 factorial number of ways. So I told you I gave a test this morning and somebody was asking me, where do I find factorial? I will not answer that question because knowing how to use your calculator is part of the test. Is that clear? So I'm not going to be telling you where to find factorial or combination or permutation on the test there. If you don't know it, then it means you missed it. That's it. I'm sorry. That's why I gave you the practice test almost 2 weeks to the test. Right? So you first of all type in 13, then go to math, arrow to PRB. Factorial is number 4. Then you hit enter. So that's billion numbers. So about 6 billion number of ways that Aaron can arrange 13 songs, taking all 13 of them at a time. Okay? That's easy. Let's go to another number. We're not going to follow it in order though. Let's go to, but this number 7 is, if we can do number 7, there are other numbers that look like number 7. So let's go ahead and do number 7. A probability experiment is conducted in which the sample space is let's count the sample space. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So sample space is 12. Sample space, I can call it sample size. So sample space is 12. Sample size, 12. Okay. I can also say NG is 4. 4G has 4. Let me call it NG. The number in G is 4. And the number in F is also 5. I hope you know that this is not probability, but the count. Now we shall now look at G and F. It seems like they're asking about, we have 2 events. So we're going to be dealing with compound events. Compound events. All right. So let's look at event F and event G. Is there anything in event F that is also in event G? 15. Okay, so we're going to make a mark there. All right. Now, since there is a common number between F and G, the question says, what is the question? Assume that each outcome is equally likely, yes? List the outcomes of F or G. Remember that or in probability means what? Addition. But there are 2 kinds of or mutually exclusive and or non-mutually exclusive. Or mutually exclusive and or non-mutually exclusive. So now I want to check, okay, that is a common number between F and G. Therefore, this is non-mutually exclusive, right? I can draw a picture. So I can draw a Venn diagram to show that it is all non-mutually exclusive. And I want you to know that non-mutually exclusive is called the general rule. So somebody can say, use the general rule to do something. General rule means all non-mutually exclusive. I also wanted to let you know that non-mutually exclusive is called joint probability or non-mutually exclusive. So I'm about to draw a Venn diagram with two ovals intersecting each other. I will call the first one F, call the second one G. The only number between F and G is 15. That is the only number in that intersection. The remaining numbers in F are going to be 11, 12, 13, and 14. The remaining numbers in G are 16, 17, 18, 16, 17, 18. All right. And then the question is, assume that each outcome is equally likely. Okay, we got that. Find P, F, or G. P general rule. That's an intersection. First of all, P probability of F or G is a general rule. You know what? Let me write it using union. It's always good to use union. So PF union G is equal to probability of F plus probability of G minus the AND, the intersection, probability of F intersection G. All right. All right. Now, what's going on there? Uh-oh, my battery is... Okay. All right, so now I want to find the probability of F. It says it's equally likely. So the probability of F is the 5 numbers in F over total. The probability of G is the 4 numbers in F over total in the universal set. What is the intersection? That's only one number in the intersection, so 1 out of 12, right? Therefore, P, F union G is equal to 5 out of 12 plus 4 out of 12 is 9 out of 12 minus 1 out of 12 is 8 out of 12. So I got an answer, 8 out of 12. Simplifying, I have 2 out of 3, but I'm told to leave my answer to 3 decimal places. What's my answer to 3 decimal places? Or my answer to 3 decimal places? 0.667. I don't want to wait. I don't want to be waiting for you because we got a lot today. Okay, so it's 0.667, 0.667. If you're told to interpret it, you can say, if you're given, if you do 1,000 experiments, 667 of them will will come out P for G. See, anytime you're told to interpret probability, you got to quantify it, because you're going to say, you can use law of large numbers. The law of large numbers is the more the repetition, the better the outcome comes out the probability. For example, if I have a coin, a fair coin, and throw it 100 times, the probability of H head coming out is going to be 1 out of 2 or 0.5, because I repeated the experiments several times. But if I do it only 2 times, maybe I can actually have head all the time. It could look like head comes out all the time. But if I do it a whole lot of time, what the law of large numbers say, then you'll see it is 50-50. Okay. Now, they want to know if we know the formula. Somebody's trying to pull our legs. Okay, what is PF or G? Is it PF plus PG equal to no? So this is not the formula. Why? There is an intersection. So So the general rule, so they're asking us to use the general rule to write that expression. So this is PF, the first one, probability of F, probability of G, minus probability of the intersection, P, F, intersection G. And then I'll put my answer here, 0.667. All right, so let's get out of here. Oh, let me stop recording. And I don't want to post